Okay, so today we're going to take a look at section 2.5, and in it I'm going to give you a polynomial, and you have two primary goals. Your first goal is that you're going to completely solve it, okay, and in this section we really talked about that when we completely solve an equation, one of the ways to start doing it for a polynomial is to do division. And then after we have done enough division, we can move on to factoring it or doing the quadratic formula. But our primary goal is number one, to solve it. And we are going to write out the solution set down here. And I'm hoping, since our original polynomial had a degree of 4, that I get 4 separate answers right there. Okay, and then the secondary goal is that we use those answers to fully sketch with the zeros. I'm going to include the y-intercept, and then we're going to make sure that we double back and verify that it matches with what we originally thought, and check in with Descartes' rule of signs. Okay, so coming back up to the top, so here is our polynomial. It has a nice degree of 4 at the very beginning, and we can see that the leading coefficient is a positive. So we know degree of 4s have some sort of shape, positives facing up, up, up. So maybe some words that we can do to describe this is that it rises to the left and it rises to the right, so that when we go to sketch, we fully get this shape going on. Okay. So then what we're going to do is we are going to think about things that are possible zeros, and that shows up with our rational zero test by looking at our constant at the end of -8 and our lead coefficient at the front, which is a +1. So all things that are factors of 8, and we just say 8 in general, +1, +2, +4, +8, and the denominator is just +1, +1. So we don't have any weird fractions here. What I do see is 1/1, which is still 1, 2/1, 4/1, and 8/1. So no weird fractions. These are possible things that when I look in my graphing calculator, I'm going to look for one of these to show up as the zeros. Okay, so for Descartes, I have taken the time to rewrite f of x all the way throughout, so it's just rewritten. And then f, I plugged in -x, and you will see what changes. Even degree stayed the same, odd degree became opposite, even degree stayed the same, odd degree became opposite, and numbers, there's nowhere to plug in, so it stays the same. So that's just the setup for Descartes. So what I'm going to do for Descartes is now I'm going to look for when the sign will change, and I'm going to mark it. So here we go. I'm going to start with a positive. So it starts as a positive. I'm going to mark it as soon as it changes. The next term is still a positive. At the next term, it changes to a negative, so I'm going to mark it right here. Now we are at a negative, the next term stays a negative, and the next term stays a negative. So because I only marked it once, I'm going to write 1. We plugged in +x right there, so we say positive real root. So this is really nice to know about our picture, because we only know that there's one possibility of it crossing the x-axis at a positive number. Okay, negative version. It starts as a positive. The next term immediately switches to a negative. I mark it. It stays a negative, switches back to a positive. I mark it, switches to a negative. So anytime it switches to the next term, I mark it. So I have 3. So when you have 3, we list that it's a possibility for any odds, 3 or 1. This is plugging in for negative real roots. So I'm going to use this fact only to check myself when we get to the final answer. that when I look at my sketch, I'm going to make sure one positive shows up and one negative shows up, or 3 negatives show up. So we will come back to this at the very end. This right here, for me, is just a check that we have the right shape going on. Okay, at this point, we are going to plug it into our graphing calculator to identify a possible root. So what I would first suggest is in your calculator, you go to Zoom and make sure it's on standard. So option number 6. So 6 and then enter. And then you're going to go to y equals and you're going to type in the function. So I bet you don't have this, so make sure you hit pause. Okay, and then go take a look at the graph. So instantly what I see is it looks like it crosses in between -3 and -4. So that's not one of my possibilities right here. I'm not going to list that right now. So my possibilities I'm looking for are 1s, 2s, 4s, and 8s. So the next thing I see is -2. That is one of my possibilities, so I am going to verify it by hitting trace and typing in -2, hitting enter, and I verify that it says 0. So for certain it goes through -2, 0. So I'm going to write down -2 right here. And I'm going to come back. Okay, it looks like it goes in between 0 and -1. That is not one of the possibilities. I don't write it down. Okay, and then the last possibility it looks like it goes through is +2. That is also one of my possibilities. So let's test it out. I hit trace. I type in +2, hit enter, and it verifies for me that it's on 0. Okay, so I'm going to come back down here, and we also said +2. What this means for me, these are the first numbers I'm going to divide out. Okay, I am going to zoom right out. So far, I've really been discussing what is this function going to be doing, and we're going to verify what's going to be happening here. So I'm going to use synthetic division until I can get to an answer I can factor, or I can do the quadratic formula for. So it doesn't matter which ones. I'm going to choose to do the -2 first, only because it's listed first. So here we go with synthetic division. I put -2 into the box, and then I pick up all the coefficients, and I'm checking for anything missing to input 0 as its placeholder. 1, 4, -2, -16, -8. If it truly is a 0, the remainder should be 0. And that will be our double check. So here we go. Drop. Multiply. Add straight down. Repeat. Multiply. Add straight down. Multiply. Add straight down. Multiply. Add straight down. And I get a remainder of 0. Okay, I'm so excited to see this because this is our first check that x equals -2 is a 0. And I can go ahead and drop it down into my answer choices. This is definitely one of the choices. You have verified that to me. Okay, we are now going to use our remaining numbers right here, and I'm going to divide out the next number listed, the +2. Continue in our synthetic division. Drop. Multiply. Add add straight down. Repeat, multiply, add straight down. Multiply, add straight down. And I am relieved to see that this is working out for us. Check x equals positive 2 is a 0. So I'm going to go ahead and come down here and list positive 2. Of course, I do not have to write in positive, but I'm just doing that so we can really see it. Okay, at this point, I am left with remainder, number, x squared. So what I have left over is 1x squared plus 4x plus 2 equals 0. So now I'm going to decide this will either factor or do the quadratic formula. I already have a giant clue. When I looked in the calculator, it was kind of a fraction, so I'm more lenient to go towards quadratic formula. But maybe we should still check out Xbox to see if it factors. But I'm going to go ahead and do the quadratic formula. So my A value is 1, B value is 4, C value is 2. All right, quadratic formula. X equals the opposite of B, negative 4, plus minus square root. B squared, positive 16, always a positive right here. Most common thing missed. Minus 4 times A times C, all over 2A. I'm going to really start simplifying. First things up, I'm going to simplify my discriminant. 16 minus 4 times 1 times 2. 16 minus 8 is 8. All over 2. Okay, I can definitely see why I'm getting decimal here. We don't know the square root of 8. Okay, so I'm going to choose to do a factor tree. 2 and 4. 2 and 2. And the 2 comes down, so 8 is 2 times 2 times 2. I'm looking for a pair. A 2 will come out, and this 2 will stay inside. So I'm going to rewrite that. X equals negative 4 plus minus 2 root 2 all over 2. So many 2's going on in this problem. I do see that we are going to reduce all the outside numbers. All of the outside numbers will divide by 2, which the denominator will become 1. So I'm really happy to see that. Negative 2 plus minus 1 root 2 all over 1. So here are my final 2 answers. And I'm going to get negative 2 plus root 2 is my first one. And then negative 2 minus root 2 is my second one. Since those are real, we can see them on the graph, you could take the time right now and check those out in the calculator to verify if they are true. Hit trace. And we said negative 2 plus root 2. Enter. The y says 0, so we are perfectly on tap with that one. And then I'm going to check the other one, negative 2 minus root 2. Hit enter, and again it pops out as 0. So we definitely found all 4. Now when we go to graph those, we probably want their decimals instead. So I'm going to type them in, negative 2 plus root 2. We're going to graph about negative 0.6 and negative 2 minus root 2 and negative 3.4. So I am going to use those to help us graph that. We are going to graph it about negative 0.6 and about negative 3.4. So up above, the solution set is the exact answers, and these I'm just using approximate to help me graph it later. All right, we have accomplished goal number 1, which I know you guys are laughing at right now because we have completely solved the equation. So goal number 1, we have completely solved the polynomial. We have our 4 answers, and now we're going to get ready for our goal number 2 to sketch it. So I'm going to come down here. Okay, the first thing I would like to do is I want to make sure for my full sketch, I am going to make sure the y-intercept. So you can plug that straight into your calculator. So we are going to plug in 0, 0 to the 4th, plus 4 times 0 cubed, minus 2 times 0 squared, minus 16 times 0, and then minus 8. We're probably going to see negative 8 pop out, but I'm going to go ahead and type that in. So here we go. 0 raised to the 4th, plus 4 times 0 raised to the 3rd, minus 2 times 0 squared, minus 16 times 0, and then minus 8. And sure enough, we get negative 8. It looks like my decimals are not on float, so I'm going to float those right now. I was on 7 for some reason. Okay, so I get negative 8. So our y-intercept we're going to make sure we put down at negative 8. Alright, I have set up just a very generic, when I say sketch, I want to make sure that I'm hitting all these key points. So, 1, it should go through negative 2 on the x-axis, positive 2 on the x-axis, about negative 0.6, so maybe about right here-ish. Okay, and then negative 3 and a little bit more. 1, 2, 3 and a little bit more right there. Okay, and on the y-axis I'm going to mark negative 8 somewhere along here. So here's my negative 8. Okay, I want to make sure I go through here. Alright, we are ready to start sketching. So, from the very beginning, we said it should rise to the left and rise to the right. So I'm going to go down to my picture right here and make sure it rises from the left and rises from the right. All of these x's were singles, so we're going to go through the x-axis as we go through them. So here we go. I'm going to go through to the next point, through to the next point, down to that negative 8 right there, and then through to the next point right there. And I have the nice full sketch of all the intercepts is what I'm looking for at this point. Okay, so goal number 2, we sketch the polynomial. Okay, check. And then what does it say down here? I want to verify the behavior. So the behavior is checked because we are rising to the left, rising to the right. Check, check. Rising to the left, rising to the right. And Descartes, I'm looking for one positive real root, and I'm looking at the photo right here, and it goes through only one positive answer right there. So that verifies what Descartes says, only one positive answer, and 1, 2, 3 negative answers. It picks up right here 3 negative answers for Descartes. So I have verified both the behavior and the rule of sign, just as a quick check of my final graph. More for our own sanity. Alright, so we have finished out our goal of completely solving this and sketching this and checking if we feel good about it. When would this be really good to use is eventually our graph will not show us all of the zeros, and some of these will be missing. So when we do the quadratic formula, we're going to have negative roots, which means we're going to have imaginary answers. So we are stepping towards this and finding all the possibilities. All right, that is all for today, and I will see you all soon.